Does marijuana use make you slow? A random selection of 28 heavy marijuana users spent an average of 38.28 minutes to complete a set of logic puzzles. Their standard deviation was 4.51 minutes. A random selection of 29 non-users spent an average of 25.4 minutes to complete the same set of logic puzzles. Their standard deviation was 3.98 minutes. Use a 1% significance level to test the claim that the population of heavy marijuana users takes longer on average to complete the set of problems than non-users. Assume equal variances. So based on the reading of this problem, it's a hypothesis test, right? Use a 1% significance level to test the claim, right? So test the claim, and it's talking about the average amount of time to complete a set of problems, right? So what we would say about this is because there's two groups. There's people who use marijuana, people who do not use marijuana. Those two groups comprise basically two sets of sample data, right? So we have two summary sets of data. We have 28 heavy marijuana users, we have their average, we have their standard deviation. We also have 29 non-users, their average, their standard deviation, right? And because of that, we're going to use the two-sample t-test. Why t-test? Well, first of all, it's a hypothesis test, because it says here to test the claim, so it's a hypothesis test. The other thing about it is that there are clearly two samples involved. So the sample sizes are small, and so that makes it a t-test. So let's go ahead and hit the stat key. We're going to arrow over to where it says test, and we're going to go down till we find two-sample t-test. That is option 4 in our calculator. All right, so we'll hit enter there at that point. And again, it wants to know if we have the data, the actual raw data, or do we have summary statistics? In other words, do we have things like n, like x bar, like s, right? If we have those things, then we should be on stats. So we do have those things, so we're going to leave it on stats. If it's not on stats, you're going to go over to where stats is and hit enter. Then you will scroll down and you will type in your sample mean for the first population. So let's go ahead and use the marijuana users as our first population because it's the first one we see. And it says their average was 38.28. So 38.28. Then we have their standard deviation. So their standard deviation was 4.51. Then it wants to know the sample size for that group, and it says that is 28. So we'll type in 28. Then below that, we want the sample mean for the second population. The sample mean for the second population is 25.4. Okay, scroll down. We need the sample standard deviation. The standard deviation was 3.98. So 3.98. That was for the second group there. And then the sample size for the second group, well, there are 29 non-users. So we'll say 29 down there. Okay, from there, they want to know what our alternative hypothesis is. So in order to figure that out, we have to know what HO and HA are. So normally when you're doing these problems, if it's a test situation or a homework situation, you should really use part of the paper and pencil method, which means I want you to write the claim, the HO, and the HA down before you start the problem. Because our main purpose here is to demonstrate the calculator use, we'll just go over what the claim would be and how that relates to HO and HA out loud. So it says, use a 1% significance level to test the claim that the population of heavy marijuana users takes longer on average. So heavy marijuana users is what we let our first population be. So that is going to be, so to speak, on the left-hand side. And if this takes longer, we'll have a greater than symbol then. And then behind that, we would have the non-users. So the marijuana is greater than the non-users, right? So the marijuana length of time to finish the puzzles is greater than the length of time for people who do not use marijuana. So we'll hit enter on the greater than symbol that's there. All right, and then we come down here and it's going to ask us that question. Do we want to pool the sample variances into one estimator, or do we not want to do that? And so that hinges on whether we say that we're assuming equal variances or we're not assuming equal variances. If we're assuming equal variances, we say yes. If we're not assuming equal variances, we say no. But we're assuming equal variances, so we're going to say yes. I'll highlight that, scroll down to where it says calculate, and hit enter. And there you get some important information. You get your test statistic. In this case, it's quite extreme. It's 11.44. You get a p-value. Be careful of the scientific notation here. That's 15 zeros before you get to the digits 1796, right? So 15 zeros because that's times 10 to the negative 16. You have to move the decimal point over here 16 places to the left, which would give you 15 zeros in front of the number, basically 180. All right, so at that point, you're basically saying that you clearly reject the null hypothesis because all those zeros, and then 180 is going to be less than 0.01, right? So because the p-value is smaller than the alpha, we reject the null hypothesis. If we reject the null hypothesis, we support the alternative. The alternative happens to be the claim here, because the claim here expresses the idea that it takes longer, so it's saying greater than, and that's an alternative hypothesis. So basically we're supporting this idea that it takes heavy marijuana users longer to complete the set of puzzles than the non-users. And again, if you scroll down in this list that came from your calculator, you will get nice things like the pooled estimator, right? S sub p, which is 4.24845191. You also have at the top the degrees of freedom for the problem, which is 55. All right, very good.